National Electrical Code Article 210.70 paragraph B requires that service lighting be provided for outdoor electrical equipment that requires servicing or maintenance. The service lighting must be controlled by a switch or circuit breaker located at the equipment. The light fixture must provide illumination at a minimum of 0.6-foot candles. National Electrical Code Article 210.63 requires that at least one receptacle outlet be provided for service equipment located indoors. The outlet must be located within 6 feet of the equipment. A radiator for cooling a generator is not considered heating, air conditioning, and refrigeration equipment. Based on the National Electrical Code requirements, service lighting and a receptacle are required for the generator and radiator. A service light must be installed on the exterior of the building near the radiator. The light must be controlled by a switch located near the radiator. A receptacle must be provided indoors within 6 feet of the generator. The National Electrical Code, often abbreviated as NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It's a comprehensive set of guidelines intended to protect people and property from electrical hazards. It's important to understand that the NEC is not itself a law. However, it's often adopted by state and local jurisdictions, thereby becoming legally enforceable. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. These updates can include revisions to existing articles, as well as the addition of new requirements. Some key articles in the NEC that are frequently referenced include Article 210, which covers branch circuits, Article 220, which deals with branch circuit, feeder, and service calculations, and Article 250, which covers grounding and bonding. In the specific case of a generator with a separate radiator, there are a few key considerations from the NEC. Firstly, the NEC requires that outdoor electrical equipment that requires servicing or maintenance must have service lighting. This lighting must provide a minimum illumination of 0.6-foot candles, and it must be controlled by a switch or circuit breaker located at the equipment. The purpose of this requirement is to ensure that technicians can safely perform maintenance on the equipment, even in low light conditions. Secondly, the NEC requires that at least one receptacle outlet be provided for service equipment located indoors. This outlet must be located within 6 feet of the equipment. The purpose of this requirement is to provide a convenient power source for tools and equipment that may be needed for servicing the equipment. It's important to note that a radiator for cooling a generator is not considered heating, air conditioning, and refrigeration equipment. Therefore, it's not subject to the same requirements as heating, air conditioning, and refrigeration equipment. When installing a generator with a separate radiator, it's essential to carefully review the NEC to ensure that all applicable requirements are met. This includes ensuring that the service lighting and receptacle outlet are properly installed and that the equipment is properly grounded and bonded. Grounding refers to the process of creating a low-resistance path to the earth. This path allows fault currents to flow safely to the ground, tripping a circuit breaker or fuse and preventing electrical shock. Bonding, on the other hand, refers to the process of connecting all metal parts of an electrical system together. This helps to ensure that all metal parts are at the same electrical potential, which can also help to prevent electrical shock. In addition to the NEC, it's also important to be aware of any local codes or regulations that may apply. These codes may be more stringent than the NEC, and they may include additional requirements. It's always a good idea to consult with a qualified electrician to ensure that your installation meets all applicable requirements. The authority having jurisdiction, or OJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, an installation, or a procedure. The AHJ can vary depending on the location and the type of project. For electrical installations, the AHJ is typically a local building inspector or electrical inspector. The AHJ has the authority to interpret the code and to make decisions about whether an installation meets the requirements of the code. The AHJ can also issue permits, conduct inspections, and enforce penalties for violations of the code. It's important to work closely with the AHJ throughout the design and installation process to ensure that your project meets all applicable requirements. This can help to avoid costly delays and ensure that the installation is safe and compliant. The specific requirements for service lighting and receptacles for generators and radiators can be found in the National Electrical Code, specifically in Articles 210.70 paragraph B and 210.63. Article 210.70 paragraph B covers lighting outlets required in specific locations, including outdoor locations. It mandates that at least one lighting outlet must be installed at an accessible location for outdoor electrical equipment that requires servicing, such as a generator radiator. The lighting outlet must be controlled by a switch located at the equipment, or be remotely controlled. This ensures that service personnel can safely and easily access the equipment for maintenance and repairs, regardless of the time of day or ambient lighting conditions. The NEC also specifies the minimum illumination level required for service lighting. As mentioned earlier, the light fixture must provide illumination at a minimum of 0.6-foot candles. This level of illumination is considered adequate for performing most maintenance tasks safely and effectively. Article 210.63 addresses receptacle outlets required for specific equipment. It mandates that at least one 125-volt, single-phase, 15 or 20 amps receptacle outlet must be installed within 25 feet of electrical equipment that requires servicing. This receptacle outlet is intended to provide a convenient power source for tools and equipment used during maintenance and repair. The receptacle outlet must be readily accessible and located on the same level as the equipment. This ensures that service personnel can easily access power for their tools without having to run long extension cords or search for a nearby outlet. In addition to these specific requirements for service lighting and receptacles, the NEC also contains general requirements for electrical safety that apply to all electrical installations. These requirements cover topics such as grounding, bonding, overcurrent protection, and wiring methods. Grounding is the process of connecting electrical equipment to the earth, providing a low impedance path for fault currents to flow back to the source. This helps to protect against electrical shock and fire hazards. Bonding is the process of connecting all metal parts of an electrical system together, creating a common electrical potential. This also helps to protect against electrical shock and fire hazards. Overcurrent protection is the use of circuit breakers or fuses to protect electrical circuits from excessive current flow. This helps to prevent overheating and fire hazards. Wiring methods refer to the types of conductors, cables, and raceways used to install electrical wiring. The NEC specifies the acceptable wiring methods for various applications, based on factors such as voltage, current, and environmental conditions. When installing a generator with a separate radiator, it's crucial to comply with all applicable requirements of the NEC and any local codes or regulations. This includes obtaining the necessary permits, using qualified electricians, and having the installation inspected by the AHJ. Failure to comply with these requirements can result in fines, delays, and potentially dangerous electrical hazards. It's also important to note that the NEC is not a design manual. It provides minimum safety requirements, but it doesn't provide detailed instructions on how to design an electrical system. Therefore, it's essential to consult with a qualified electrical engineer or designer to ensure that the electrical system is properly designed and installed. In addition to the NEC, there are other standards and guidelines that may be relevant to the installation of a generator with a separate radiator. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, also known as IEE, and the National Fire Protection Association, also known as NFPA. The IEE develops standards for electrical engineering, including standards for power generation, transmission, and distribution. The NFPA develops codes and standards for fire safety, including the National Electrical Code. These standards and guidelines can provide valuable information and guidance on the design, installation, and operation of electrical systems. In summary, when installing a generator with a separate radiator, it's essential to comply with all applicable requirements of the NEC local codes and other relevant standards and guidelines. This includes providing service lighting and receptacles, properly grounding and bonding the equipment, using appropriate wiring methods, and obtaining the necessary permits and inspections. By following these guidelines, you can help to ensure that the installation is safe, reliable, and compliant with all applicable regulations. Furthermore, understanding the specific requirements outlined in NEC Articles 210.70 paragraph B and 210.63 is crucial. These articles clearly define the necessity of service lighting and receptacle outlets for equipment requiring maintenance, ensuring the safety and convenience of service personnel. The service lighting, as mandated by 210.70 paragraph B, must provide a minimum illumination level of 0.6-foot candles and be controlled by a switch located at the equipment. This ensures that service personnel can perform maintenance tasks safely and effectively, regardless of the time of day or ambient lighting conditions. The receptacle outlet, as required by 210.63, must be a 125-volt single-phase, 15 or 20 amps outlet and must be located within 25 feet of the equipment requiring servicing. This provides a convenient power source for tools and equipment used during maintenance and repair. It's important to note that the NEC is a living document that is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Therefore, it's essential to stay up to date on the latest changes to the NEC and to consult with a qualified electrician or electrical engineer to ensure that your electrical installations comply with all applicable requirements. Finally, remember that the AHJ has the final say on whether an electrical installation meets the requirements of the code. Therefore, it's crucial to work closely with the AHJ throughout the design and installation process to ensure that your project is approved. The selection of appropriate wiring methods is also critical for ensuring the safety and reliability of the electrical system. The NEC specifies the acceptable wiring methods for various applications based on factors such as voltage, current, and environmental conditions. Common wiring methods include rigid metal conduit, electrical metallic tubing, flexible metal conduit, and cable assemblies. The choice of wiring method depends on the specific application and the environmental conditions. For example, rigid metal conduit is often used in hazardous locations or where mechanical protection is required. Electrical metallic tubing is a lighter weight alternative to rigid metal conduit and is often used in dry locations. Flexible metal conduit is used to provide flexibility and to connect equipment that is subject to vibration. Cable assemblies, such as non-metallic sheath cable, are often used in residential wiring. In addition to the wiring method, it's also important to select the appropriate size of conductors for the electrical circuits. The NEC specifies the minimum size of conductors based on the ampacity of the circuit and the ambient temperature. The ampacity of a conductor is the maximum current that it can carry continuously without exceeding its temperature rating. The ambient temperature is the temperature of the surrounding air. The NEC provides tables that list the ampacity of conductors for various sizes and types of insulation. When selecting conductors, it's important to consider the dating factors that may apply. Dating factors are adjustments to the ampacity of a conductor that are required under certain conditions, such as when multiple conductors are bundled together or when the ambient temperature is high. These factors reduce the ampacity of the conductor to ensure that it does not overheat. The generator size of 350 kV is an important factor to consider when determining the electrical requirements for the installation. A 350 kV generator can supply a significant amount of power, and the electrical system must be designed to safely handle this power. The generator's voltage and phase configuration will also affect the design of the electrical system. Generators are typically available in various voltage and phase configurations such as 480 volts, 3-phase, or 208 volts, 3-phase. The voltage and phase configuration must be compatible with the electrical system to which the generator is connected. The location of the generator and radiator is also a factor to consider. Since the generator is located inside the building and the radiator is located outside, the electrical connections between the generator and the radiator must be made in accordance with the NEC requirements for outdoor wiring. This may require the use of weatherproof enclosures and fittings to protect the electrical connections from the elements. Finally, it's important to consider the potential for future expansion when designing the electrical system for the generator. The electrical system should be designed to accommodate future increases in load, such as the addition of new equipment or machinery. This may require the installation of larger conductors, raceways, and overcurrent protection devices. By considering these factors, you can ensure that the electrical system for the generator is safe, reliable, and capable of meeting the current and future power needs of the facility. The NEC provides detailed guidance on the installation of generators, including requirements for grounding, bonding, overcurrent protection, and wiring methods. The NEC also specifies the requirements for emergency power systems, which are used to provide power to essential loads during a power outage. The NEC defines essential loads as those that are necessary for the safety of life and property, such as emergency lighting, fire pumps, and critical care equipment. Emergency power systems must be designed to automatically start and transfer power to essential loads within a specified time period after a power outage. The NEC also specifies the requirements for the maintenance and testing of emergency power systems. Emergency power systems must be regularly inspected and tested to ensure that they are in proper working order. The inspection and testing must be performed by qualified personnel in accordance with the manufacturer's recommendations and the requirements of the NEC.